Alright, solve for x. So number one here, x plus 6 equals 17. So to undo that addition, we need to subtract 6 from both sides. So x is going to equal to 11. Next one here, 153 equals m times n. So to undo that multiplication, we divide both sides by 9. So we get 17 equals 2m. Alright, Mr. and Mrs. Gutierrez borrowed $10,500 to buy a new car. The loan is to be paid off in 35 monthly payments. How much is each payment? Alright, so this sounds like long division here. So I'm going to take 10,500 and I'm going to divide by 35. 35 will not go into 10, but 35 will go into 105. So 105 divided by 35 is 3. Multiply back. 3 and 35, that's going to be 105, which is 0. 35 will go into 0 times, bring down our next 0. 35 goes into 0 times there. And so that way each payment is going to be $300. So here, since it was being paid off in 35 months, we needed to take 10,500 and divide by 35. Alright, simplify. So these are our order of operations. Remember our B PEMDAS. So start with brackets and or parentheses. We have no brackets. We do have parentheses. Bring everything else down. So we've got 12 squared plus 12 times 8 minus, inside here we do the multiplication first. So we're going to do that 4. Alright, we've got 2 times 2, so that's going to give us 4. Alright, and then we still have some parentheses here we can do. So 12 squared plus 12 times 8 minus 8 plus 4. So that's going to give us 12. Alright, so inside the parentheses we can't do anything else now, so we can do exponents. So we've got 12 squared, so 144, plus 12 times 8 minus 12. I can drop the parentheses because nothing else simplifies there. So now I've got multiplication next, so 144 plus our 12 times 8, so plus 96 minus 12. And then remember, multiplication and division, as well as addition and subtraction, get done from left to right like reading a book. So we're going to add first, so 144 plus 96, which is 240, bring down our 12, and then we're going to subtract 12. And so that's going to give us 228. Alright, next one here. Again, we're going to do inside our parentheses first. We'll do the first set of parentheses. So we'll do this 5 minus 9 first. Bring everything else down. 12 times 11 minus 15 minus 9 there. That's going to give me 6. Keep bringing down everything else. And then we do have another set of parentheses, so the next set there is that 9 minus 7. So 12 times 11 minus, I can drop the parentheses because nothing else inside of those, divided by 3 minus 2. Alright, and so again, still looking through our order of operations, no more parentheses, nothing can be done inside. We have no exponent, so multiplication and division get done from left to right like reading a book. So we're going to do this 12 times 11 first. And that's actually 132. So 132 minus, bring everything else down. I can drop those parentheses because I can't do anything else inside. And then the next thing up here is division. So I've got 132 minus 2 minus 2. And then we do the subtraction from left to right. So 132 minus 2 is 130 minus 2, which equals 128. So remember, with order of operations, we go from left to right, do everything in parentheses and brackets first, simplify as much as possible, then our exponents, multiplication, division, and addition, subtraction. Alright, number 6 here, find prime factorization of the number. So remember, prime factorization meant that we were breaking this number down into all of its primes. And then we did have our divisibility rules. So remember that if the sum of the digits, so 2 plus 3 plus 1 is 6, so if the sum of the digits is divisible by 3, then the number is also divisible by 3. So if we're trying to figure out how prime factorization here, right, sum of the digits is divisible by 3, the number is divisible by 3. So 231 divided by 3 is going to give me 3 and 77. So remember the prime factorization, we go cherry picking, so 3 is prime, so that is one of our cherries here. 7 and 11 would make us 77, those are both prime. So the prime factorization of 231 is going to be 3 times 7 times 11. Alright, multiply and simplify. So remember when we multiply fractions, we multiply straight across. But remember that whole numbers can be rewritten as fractions, right, over 1. So 7 over 8 times 22 over 1. Multiply straight across, so 7 times 22 over 8 times 1. And we see that 22 and 8 both share a factor of 2. So 22 divided by 2 is 11. 8 divided by 2 is 4. So this is going to give me 7 times 11 over 4 times 1, which is 77 over 4. Alright, when we divide fractions, same as the multiplying, right? But what we need to do is flip the second fraction first, and then we multiply. So this is going to be equal to 4 over 9 times 5 over 7, which will be 4 times 5 over 9 times 7. I'm not seeing any common factors there, so that's just going to be 20 over 63. Alright, number 9 here. Same thing, if we have a whole number, we can write that as a fraction over 1, so 8 over 1 divided by 2 over 5. We always flip the second fractions to multiply. So flip and multiply, which is going to give me 8 times 5 over 1 times 2. 8 and 2 both share a factor of 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So this gives me 4 times 5 over 1 times 1. So 20 over 1, which is just 20. So remember, when we multiply fractions, we multiply straight across. If it is a whole number, write it over 1, multiply straight across. And then when we divide fractions, we flip the second fraction and multiply. Add and simplify. Alright, so remember, kind of when we add fractions, and this is the same for subtraction, right? We have to have a common denominator. Alright, so looking at this first one here, 7 over 6 plus 5 over 18. Well, I can turn 6 into 18, right? So I'm going to take 7 over 6, and that's going to be something over 18. Well, I can multiply the top and the bottom by 3. So to do the bottom, I have to do the top to keep them equal. So this gives me 21 over 18. So our original problem is now going to be 21 over 18 plus 5 over 18. Now that I have a common denominator, I can just add my numerators and I keep the denominator. So this is going to give me 26 over 18. And we see that these both share a factor of 2, so we can simplify. 26 divided by 2 is 13. 18 divided by 2 is 9. So this will simplify to 13 over 9. Alright, same thing on number 11 here. It's just we happen to have 3 numbers, so we want an LCD for all 3. So it's actually, let's see, we've got 8, 10, and 18. So I'm not seeing anything quick there. Remember that we can find the LCD by doing the prime factorization of each of our numbers. So I went cherry picking here. I got 2, 2, and 2. So the prime factorization of 8 is 2 cubed. For 10, that's going to be 2 and 5. Cherry picking, there we go. So that's 2 times 5. And then for 18, that's going to be 2 and 9, 3 and 3. So the prime factorization for 18 is going to be 2 times 3 squared. And remember, when we're trying to find the LCD for the prime factorization method here, we take the highest degree of each factor present. So we're going to pick up our 2 cubed because that's bigger than 2 to the first power for 10 and 2 to the first power for 18. We're going to pick up 5 because there's no other 5s, and we're going to pick up 3 squared. So our LCD here is going to be 2 cubed times 3 squared times 5. So that's going to be 8 times 9 times 5. And so that's going to get me 360. Alright, so now we need to convert each one of our fractions here. So 6 over 8 with something over 360, 9 over 10 with something over 360, and 5 over 18 with something over 360. So 360 divided by 8 is 45. So I'm going to multiply the top and the bottom by 45. So I keep these equivalent. So 45 times 6, that's going to be 270. 36 times 10 will give us 360, so I'll multiply the top and the bottom by the same number to keep these fractions equivalent. So that's going to give me 324 over 360. And then 20 times 18 will give me 360, so multiply the top and the bottom again, keep these fractions equal. That gives me 100. So my original problem will now be 270 over 360 plus 324 over 360 plus 100 over 360. So I can add all the numerators, keep the denominator. 270 plus 324 plus 100 all over 360. And that gives me 694 over 360. And it looks like these are both divisible by 2, so 694 divided by 2 is going to give me 347. 360 divided by 2 is going to give me 180. So my final answer here is 347 over 180. So remember, when we add or subtract fractions, we have to have a common denominator. If that common denominator is not very obvious, like number 10, we can always use that prime factorization technique to find it. Alright, subtract and simplify. So this one actually happens to have a common denominator already. So this is going to be 13 minus 3 over 14, so 10 over 14, which is going to simplify. They're both divisible by 2 here, so that gives me a 5 and a 7. So this is going to equal to 5 over 7. Solve and simplify. Alright, so for this here, right, we need to undo what's happening. So to undo that addition, I need to subtract 1/3 from both sides. So now I have x equals 6 over 7 minus 1 over 3. But to subtract these, I have to have a common denominator. So let's come to the side here and convert. Looks like 7 times 3, since they're both prime, so 21 is what I'll need. And then 1 over 3 with a denominator of 21. So I'll multiply the top and the bottom of 1/3 by 7, which will keep those fractions equivalent. And 3 in the numerator and denominator for 6 over 7, so that gives me 18. So x is equal to 18 over 21 minus 7 over 21. X is equal to, I can combine the numerators now, 18 minus 7, so x is equal to 11 over 21. And that won't simplify any further.